The goal of this experiment was to successfully synthesize 9-fluoronol via reduction of 9-fluoronone with sodium borohydride. The alcohol will then be purified by recrystallization and analyzed by IR and Lucas test. Before starting any experiment, proper safety equipment such as safe lab attire, goggles, and gloves are mandatory and must be worn at all times. A sample of 9-fluoronone was added to a flask and dissolved in methanol. Sodium borohydride was then added and the reaction was swirled for about 15 minutes. Over time, the solution should turn colorless. During this time, a TLC was taken to monitor the progress of the reaction. In a small beaker, a small amount of TLC solvent, in this case 1:9 ethyl acetate to hexane, was added, enough to coat the bottom of the beaker. The TLC plate was then spotted. 3 spots were made. The first spot is a sample of pure starting material, fluoronone. The last spot is a reaction material. The middle spot is a co-spot. Remember that the co-spot is spotting everything. The TLC plate is then added to the TLC chamber and the solvent is allowed to elute up the TLC. About a centimeter from the top, the TLC plate is taken out and the solvent line is marked. As you can see, not much is visible in the case, such as the case of the spinach pigment, so the TLC plate must be seen under UV light. Here, the spots are much clearer. As you can see, there is not any starting material left in the reaction mixture. This means the reaction is done. The spots are then circled so the RFs can be calculated. To quench the reaction, 3 molar sulfuric acid is added in parts. Adding in parts will alleviate the fizzing of excess borohydride reacting with the acid. The product is then heated to redissolve the precipitate. If necessary, more methanol was added. The flask is then cooled to room temperature and added on ice. The product is then filtered and washed with water. The fluoronol is then continued to be washed until the pH of the water coming out of the funnel is neutral. This ensures that all the acid is removed from the product. Once all the acid is washed, the crude fluoronol is then recrystallized. The recrystallization solvent we will be using is methanol. The crude fluorinol is added to a beaker and dissolved in the minimum amount of hot methanol. Once dissolved, it is placed on the bench to cool to room temperature. After it is cooled to room temperature, it is put on ice. The crystals should form at this point. If there are no crystals forming, then some solvent should be boiled off. The crystals are then filtered through vacuum. Suction is continued to be applied to remove any solvent. Once the crystals are suction dried, they are masked so a % yield can be taken. The analysis of the 9-fluorinol will begin with a Lucas test. For this test, we will be comparing our product, a secondary alcohol, to 2 other alcohols, the tertiary alcohol T-amyl alcohol and ethanol, a primary alcohol. About 1 milliliter of each was added to a test tube, followed by a milliliter of Lucas reagent. The test tube contents were then mixed and observations were made based on the reactivity of each alcohol to the reagent. The fluorinol was then analyzed by IR. Before analyzing a sample, a background scan must be taken. This will help tear the system. Once a background is taken, a small amount of the sample is added on top of the ATR optical sampler and the hammer is then dropped. This will help press the solid to the diamond, minimizing any air gaps. The spectrum is then taken and any relevant peaks were labeled and printed.